This lesson is for Mrs. Cucci's College Now Pre-Calculus class. We are on lesson 6.4, inverses of the trig functions. So if you want to go ahead and get your notebook open, we'll get started. Okay, so by the end of this lesson, you should be able to do the following 4 things. First, you should be able to find values of the inverse trig functions. Second, simplify expressions involving compositions such as sine inverse of x, pardon me, and sine inverse of sine x. You should also be able to simplify expressions involving compositions such as sine of cosine inverse of a half without using a calculator. And lastly, simplify expressions involving compositions such as sine arctan of a divided by b by making and drawing reading off appropriate ratios. So we have a little bit of work to do, and the majority of this is new information that you guys have not seen before. So be sure to take thorough notes and come prepared with any questions that you have after this lesson. Okay, so the first thing we're going to talk about is how we go about restricting ranges in order to define inverse functions. When we think about sine and cosine, we know that if we were to take their graph and take the inverse of it and graph it, it's no longer going to be a function. So we wind up having to restrict the range so that it remains a function when we take the inverse. Okay. Remember, when we take the inverse, for example, of y equals 2x, what winds up happening is our x and y, or our domain and range, kind of trade places. Okay. So similarly, if I had y equals sine of x, the inverse is going to look like x equals sine of y. So that domain and range trade places. Okay. So if I were to take a look at the graph of x equals sine y, for instance, it's going to look a little bit different. Okay. So here's my axes, and normally we see along our x-axis 1, 2, 3, 4, and along our along our x-axis 0, pi over 2, pi, 2 pi, and so on and so forth. And along our y, we would see 1, 2, 3, 4. Since our domain and range are trading places, those values also are going to be trading places. Okay? So, for example, this is now going to be 1, 2, 3, 4, and similarly. So along my y-axis, I'm going to have pi over 2, pi, 3 pi over 2, and 2 pi. And same thing if I go down to my negative y. Okay. So when I go to graph this, normally we think about sine. We're thinking in terms of the unit circle, right? Sine at 0 would be 0. Well, even if I take that point 0, 0, and I take the inverse, I'm still going to be at 0, 0. Okay? Then at 90, or pi over 2, we would see this become 1. Sine becomes 1, so 0.10, right? So what you're going to see is at pi over 2, we're going to be 1. Okay? And then what winds up happening is at pi, we go back to 0. At 3 pi over 2, sine goes to negative 1. And at 2 pi, we go back to 0. So we kind of see this flip-flopped sine curve, right? If I were to take this and I were to rotate it this way, right, it would look like my regular sine curve, except we're kind of upside down. And then if we're going backwards, if we're going in this direction, then we're going to be back at negative 1, and then at 0, and then at 1, and then at 0. So we wind up with this curve. Now the problem is, when I take this and I look at it, this is not a function. I could pass a vertical line through this and notice it crosses in more than one location. So it's not a function. So I need to restrict my range so that it is a function. Okay? So what piece of my curve do I want in order for this to remain a function? So that piece, if we include that first quadrant, which we want to, is going to be this section right here. Okay, so we want the value on the x-axis from -1 to +1, but since I'm restricting my range, we're going to restrict it from -π/2 to π/2. Okay, so let's look at what that would look like for cosine as well, and then tangent. Okay. Okay, so cosine generally starts at 1, so the point would become 1, 0. So we're going to start here. All right. At π/2, cosine is 0. At pi, cosine is -1. At 3π/2, it's 0. And at 2π, it is 1. Okay, so that's just making your way around that unit circle. Okay. So if I'm going backwards here, we follow my trend. 0, -1, 0, 1. Place in my inverted cosine curve. And again, notice that this is not a function, so we want to include the first quadrant. So the piece that I'm going to take this time is going to be a little bit different. I want this. Okay. Okay, so we have one more to look at, and that's our tangent function. Okay, so something that we know about tangent is that at π/2 and at 3π/2, we wind up with asymptotes. Okay, so we're going to do the same thing along our y-axis because we've adjusted our values here. And we're going to place those in as horizontal asymptotes. Okay. Now we know that at 0, tangent is 0, and at pi it's 0, and 2π it's 0. So we're going to put those zeros in. Now what this winds up looking like is just like a tangent function, but inverted. Okay. So there's your tangent. And now again, if we're restricting that domain, the piece that we're going to want, because we want to include that first quadrant, is right here. Okay, so from these drawings, what we can infer, you're going to want to write this down. Okay. When I have y equals sine inverse of x. Another way to say that is arc sine of x. Okay, you're going to see that notation as well. And that's where x equals sine y. Okay. Your domain is -1 to 1. Your range is -π/2 to π/2. And notice those are included. Cosine inverse of x, or arc cosine, where x equals cosine of y. Your domain again, just like with sine, is negative 1 to 1, but your range now becomes 0 to pi. Okay, because we want to include that first quadrant and then keep it so that it can be pass that vertical line test and be a function. Tangent inverse of x, or arctan, where x equals tangent y. Now this is going to be a little bit different. Our domain is negative infinity to infinity, and notice those are not included. Our range, and again, not included because of those horizontal asymptotes, negative pi over 2 to pi over 2. Okay, so those are going to be your domain and your range for your inverse trig functions. Okay, so what that might look like on the unit circle, if we're talking about arc sine or sine inverse, okay, you wind up with your unit circle, right? So your restricted range is going to be from here to here, okay? This is negative pi over 2, this is pi over 2. For cosine, we're talking 0 to pi, so we're here to here. And last but not least, tangent. And we're not including, so we have to be cautious there. Remember that there is a way to represent that not included, and you need to make sure you do that. Okay, so if we're from negative 2 pi to 2 pi, you're going to have your open circles here, and then include this portion. Okay, so that's what those restricted ranges look like on a unit circle. Okay, so let's look at my first example. We're going to find each of the following. So we want sine inverse of square root of 2 over 2. Okay, so another way to say find sine inverse of square root of 2 over 2 is to find an angle, we call it beta, such that sine of beta equals square root of 2 over 2. Okay, and we have to be in the restricted domains from negative pi over 2 to pi over 2. So we need to figure out, in other words, another way to write this is sine at what angle equals square root of 2 over 2. And we want to be on that restricted domain in the first and fourth quadrant. Okay? So, when is sine equal to square root of 2 over 2? Well, you guys should automatically know that that's an easy one. That's an exact value. At 45 degrees, sine is equal to square root of 2 over 2. Or pi over 4. Okay, in radians, which I need you to get used to because we're going to be doing mostly radians. Okay? So, pi over 4 of 45 degrees is what we're looking at. Now, if we keep in mind that sine is also positive in the second quadrant, we can kind of go there as well. But for right now, I want you to stick on our restricted range. Okay, so cosine inverse of 1/2, or at what angle theta is cosine equal to 1/2. And remember, I want you to stay on that restricted domain or restricted range. So our restricted range for cosine was from 0 to 180. Okay, the only place we see cosine being 1/2 is in this first quadrant. In the second quadrant, cosine is negative, so I can't have that angle. So where is cosine equal to 1/2? Well, that's going to be 60 degrees. Or, in radians, pi over 3. Oops, sorry, that's where it's positive. Okay, so I don't want this. I want where it's negative, and I lost my negative sign. That would be helpful, wouldn't it? Okay? So throw that negative in there. Where is it negative? So in the first quadrant, it's positive. Second quadrant is where it's negative. But that pi over 3 is helpful to me because that's my reference angle. Okay? I need my reference angle to find in the second quadrant. To find in the second quadrant, remember my rule for quadrant 2 is pi minus the angle. So we're going to do pi minus pi over 3, or 3 pi over 3 minus pi over 3, which is 2 pi over 3. So in radians, cosine is equal to negative 1/2 at 2 pi over 3. In degrees, 2 pi over 3. You could also say 180 minus 60 is going to be 120 degrees. So there's your radians, there's your degrees. Okay. So let's try one more of those. And again, we're staying on a restricted range. Make some room right in here. So here's C. And we're going to do tangent inverse of negative radical 3 over 3. Again, we're staying on our restricted domain, which for tangent is negative pi over 2 to pi over 2. Okay, so I want to know where it's equal to negative radical 3 over 3. And again, you guys should have these memorized, okay? So tangent of something equals negative radical 3 over 3. So if you remember correctly, tangent is radical 3 over 3 at 30 degrees, or pi over 6. But again, that's where it's equal to a positive. We're going to want it in the fourth quadrant here. Okay, this is first quadrant, that's positive. Fourth quadrant's going to be negative for us. Okay, so the rule there is going to be 360 minus, if we're dealing in degrees, or 2 pi minus if we're dealing in radians. Okay, so I can adjust this, and I can make this 12 pi over 6, which is 11 pi over 6. Okay. Another way we could say this is, instead of doing 330, I could also say that it's negative 30 degrees, or negative pi over 6. And that would just be changing the rotation. Instead of going all the way around this way, I've gone this way. Okay, so you also have to know how to do this in your calculator, which really should not be difficult. So let's take a quick look at that, and then that's all we're going to do for today. All right, so the examples I want to look at is we're going to do cosine inverse of negative 0.2689. Tangent inverse of negative 0.2623. Okay, so I'll just show you how to do those real quick in your calculator. I should only really have to show you that once. You should remember this from before. Okay, so you're going to enter the calculator page. Now, remember, it matters if you're in degrees or radians. So if you want your answer in degrees, you better be in degrees. If you want it in radians, you better be in radians. Okay? So to enter this, all you're going to do is you're going to hit your trig key. You're going to select cosine inverse. And you're going to type in exactly what you see. Negative 0.2689. And in degrees, we're going to get that as 105.6 approximately degrees. If I want it in radians, I got to come up here and click. Go to my handheld document settings and change from angle from degrees to radians and click OK. Now what you can do is you can go select that, and now it'll be in radians, 1.8430 radians. Okay, so that's all you need to do for those. So please make sure that you know how to change your mode so that you can get the appropriate answer. Okay, that's all we have time for today. So next class we'll pick up with composition of trig functions and their inverses. So again, make sure that you have any questions, that you have them written down, and you're ready for class tomorrow. All right, thanks guys.